Right, moving inside, we're going into the utility room now, and you can see that all the walls have been plastered and we've got a bit of white paint on the wall, so we can now hang the internal unit for the air source heat pump. So if you saw on my previous video, we was going to have a little bit of an issue with that filter, so you can see it's just protruding out of the wall there. So we're going to have to cut some sort of access panel for it, just so it can be serviced in the future. But this has ended up okay. So what I'm going to do is get my frame hung on those pipes, get it all tightened up, get it leveled, and then I should be able to secure the frame into the noggins up there, and then we can get this internal unit hung. So by doing a good first fix, hopefully this bit should be quite nice and easy. So I've just found all the washers, so let's get this hung and on the wall. That is the frame now secured to the wall. So that was a stud wall, so they did kindly put noggins in for me. You do get some masonry bolts with it. Now the internal unit is actually pretty heavy, so you need to make sure that is nice and secure. Don't be trying to hang that on plasterboard fixing. So those pipes have all lined up pretty well, which is great. So what we need now is the internal unit, and that is this big white boiler looking thing here. So it is pretty heavy, but it just hooks onto that hook onto that bracket, and it should line up pretty well with the valves that we've just installed on the wall. So let's get this hung. That is the internal unit on the wall, so it is a little bit of a struggle by yourself, so I would recommend 2 people for this. So on the bottom of the internal unit, you've got these copper spigots here, and at this stage what you need to do is make sure you've got the unit lined up with all your brass connections, and then you need to locate these 2 boxes. So we've got that box there, upside down, I apologise, and that box there, and then inside those 2 boxes we've got the rest of the brass connections and also the copper spigots, as well as the O-rings and the washers and the PRV set. So what I'll do is I'll show you how to connect it up now. Right, when you've finished all the connections, this is how it should look underneath. So you've got flushing facilities on this manifold here, so that makes it really helpful. Now, I don't believe you actually need to use this manifold to comply with manufacturer's instructions. You could, if you wanted to, go straight off of these spigots here. I have done that previously with some isolation valves, but in all honesty, it is worth buying a jig. Makes it a lot easier when you're first fixing also. Now, one thing I didn't mention in part 1 of this video is this unit actually has a PRV. So I have already put a waste pipe underneath this unit. It's supposed to be having a washing machine directly underneath, so we had to put one there anyway. But you get this plastic tube which slides through there, very similar to the Viessmann's gas boiler range. And that just pushes on there like so, and then just sits in that hole. So you do need to connect that up to your drain or take it direct outside. Right, when you hang this internal unit, you'll actually notice that the front controller's missing, or the front HMI. Now that is a control panel. That is pretty delicate, so they actually pack it in a separate box. So when you go through all the Viessmann accessories, it comes in this long box like this. Now, I'd advise you to get this on as soon as you've hung it, because it is quite delicate, and the last thing you want is someone standing on that or dropping something on site. So let's get that panel installed. Right, to install this HMI unit, it's pretty simple. It literally just pushes in. So don't push it right in the middle of the screen, because obviously that's quite delicate. But if you just line it up like so, and then just slightly push on the edges, and that's it. It just clicks in nice and simple. This is the unvented cylinder I'm going to be installing with this air source heat pump. So it has come from Viessmann, but I'm not sure who put the sticker on, but they must have had a few beers the night before, because that is pretty pissed. Now, I must admit, this cylinder doesn't ooze quality compared to the other Viessmann components you actually get when you order an air source heat pump. So in all honesty, unless they change these, I probably might start fitting third-party cylinders, which is obviously absolutely fine, you can do. The last couple I've had, they work absolutely fine, but they just come a little bit dinged up, few scratches, stuff like that, and it's clearly just another branded cylinder with a sticker on it. So I wish Viessmann would get that sorted out, because it's not just me, the customers are noticing as well. So hopefully they'll get on top of that. But this is a 250 litre indirect heat pump cylinder, probably cost about £1,000. So yeah, it's not exactly cheap. So it should come at least in protective packaging that's a little bit better to protect it from any impact. So let's run through the connections though. So obviously we've got our pressure relief here, or temperature relief I should say. We've got our secondary return. You've got a couple of options for your stats. So if you wanted to put a stat on the top, you could. Now the coil on these, it is an inch connection, but it's 22mm pipework off the bottom of that internal unit. So you usually have to bush down out of these or use a reducing compression fitting. So we've got a flow at the top and then our return at the bottom. And you can see here we've just got our standard immersion heater, another control stat pocket, which is eventually where we'll put our 10k ohm sensor. And then we've got our cold fill at the bottom. So pretty standard cylinder, I would say, nothing really too unconventional. So let's get this in location and work out where we're going to put all our pipework. Moving over to the airing cupboard where the cylinder is going to be going, you can see it's been plasterboarded and they've just put a white coat on the walls for me so I can start getting this pipework into position. So over here on the left we've got our hot water return pipe, that's this one here, hot, balance cold, cold water main. And then if you remember from the first video, we've got our underfloor heating for upstairs on the 12mm. Over here at the back, we've got our underfloor heating flow, underfloor heating return, cylinder flow, cylinder return down there. And then we've got our 16mm manifold to pick up for downstairs. So because the waste pipe works at the back for the PRV, really I need to get that in location first. So what I'm going to do is get the cylinder in, just see how we look space wise, and then start working out a plan of action regarding the pipe work. So let's get the cylinder into position. Right, I always find it's hard to know exactly how much room you've got till you actually get the cylinder in location. So what I'm going to do is just put it in the corner for now. Probably need to screw that back first, don't I? Just chuck her in there. And then see what we've got to work with. Chuck her at the back. Okay, so we're actually pretty roomy, to be fair. Don't know what I was whinging about. We've got plenty of room. It's obviously, you wouldn't be able to put the internal unit in here, but having the internal unit sort of next door makes this a lot easier to work with. So got plenty of room on the right hand side to get our flow and return into our manifolds. Going to try and keep the hot and cold stuff up on the left hand side. Might put the expansion vessel or directly on that back wall there. Obviously you've got to bear in mind that you want your immersion heater to be accessible if you need it to be removed. So pretty much will probably be like that. So the first thing, like I said, I need to do really is pressure relief valve. So we've got a temperature relief valve on the cylinder and a pressure relief valve on the multifunctional cold water valve. So I'll probably get that into position and then I can drop it into the waste pipe. But looking at it now, looks like it's going to be a bit of a breeze. Right, that is the multifunctional valve in place. So what I've done is on the balance card, I've just left the T for now because I know there's going to be a high level cistern on the other side of this wall. So once I bring the pipe through the wall, I'll be able to tee it onto here. Also need to allow a feed for my central heating fill. So in my mind, I'm going to be putting the expansion vessels, so potable water and central heating on this back wall here with a filling loop somewhere underneath. So what I've done is, because the cold feed to the cylinder is actually on the bottom right hand side, I've dropped the pipe all the way down and just left a leg there so I can join onto it. I've also cut into this waste pipe here and put in a T-piece. So this pipe here is going to be for my pressure relief valve. So I've just added a ton dish, or a hot ton I think they're called, from a Calpine. So my PLVs are going to drop straight into that. So what I'm going to do now is put the cylinder in location. Obviously the floor is not finished, so I'm going to sort of emulate that and pack it up from the floor and start to get this piped up, and then I'll have a better idea of how it's all going to look and where everything's going to go. Okay, she's in. So I've just jacked her up on some 28mm because that's roughly what we believe the tar finish is going to be. So yeah, ample space in there really. So you can see here, I'm just literally going to join the hot up to here. Now this cylinder is going to have to come out obviously for the floor finish, so I'm not going to like finalize any of the connections, but I'm just going to get it pre-piped up, and then that cold feed that I've sent round, which is that one there, that is literally just going to join up to that. Then we've got our return pipe, which is the same height as that roughly, and then cylinder flow is a little bit higher, but we'll work with that and we'll get it right. So right, that is the hot and cold now plumbed into the unvented cylinder. So as you can see, I've added the potable expansion vessel just on the top there. Struggled to find a stud, but did find a fixing in the end. We've also got the hot water return pump here, so that's worked out okay. Just dropped straight in here. Check valve on it. I must admit, I've totally forgot to put the cable in. So if you're using a domestic hot water return pump, you need to put a cable from here to your internal unit. So that's something I definitely missed on the first video. So yeah, we're pretty much done on the hot and colds now. So like I say, I've got the flow and return into the cylinder as well from the internal unit. They've pretty much lined up as I wanted them to be. So got the heights pretty much okay, within sort of 10mm anyway. So got some bends around there just to keep out of the way of what we're going to be doing next. So the main thing that we're going to be working on now is obviously the heating. So regarding the underfloor heating, both the downstairs and the upstairs manifolds, they're all designed to run at the same flow temperature. So technically I can just join them up with no diverter valves, no mixers, and it should run absolutely fine as designed. The issue is the customer has actually asked for a way to turn off the upstairs circuit separately. Now, that wouldn't normally be a problem with a gas boiler, but with an air source heat pump, we want to try and keep all the water circulating throughout the system as much as possible. That's just going to keep the efficiencies high. So what I'm actually going to do is I'm going to fit an SB valve, which you can either use as a mixer or a diverter. So I'm not exactly sure what I'm going to do in terms of, am I going to try and keep it as a mixer, explain to the customer that we can run upstairs at a lower design temperature or lower flow temperature, or use it as a diverter so they can actually shut it off totally. Now, we should be fine in terms of the volume of water we've got in the system, because we've got all the underfloor heating downstairs. As you can see, we've got quite a big system down here, and also there is a mini buffer inside that internal unit, so I'm not too worried about that. But we don't really have the space to be adding loads of mixers, additional pumps, stuff like that. So I'm going to fit an SB valve for now and tee that into this upstairs manifold. Now, regarding the pipework, hopefully it's going to be quite simple. So we've got our flow and return here, and I just need to tee off and then go into the flow return of both underfloor heating manifolds, as well as incorporating that SB valve. So what I need to do is get this cylinder out, because it still needs to be tiled underneath. And yeah, let's work out how we're going to get these manifolds plumbed in. Okay, that is the pipework all complete in the airing cupboard. As you can see, I've got the flow and return in 28mm pipe work, used the pipe bender, and I've also added an SB valve. So this valve is a diverter valve, but can be used as a mixer. So the client wants to make sure they can turn the upstairs floor off. So I'm not exactly sure if I'm going to wire that into a stat or try and use it as a mixer at this stage. So I'll decide that when I start commissioning it and wiring it all in. So yeah, kept it 28mm up to the underfloor heating manifold. No zone valves at all on this other than that diverter that I've just added. Another thing to mention is you don't need to put a zone valve on the flow and return to the cylinder. So all you have is the 10K ohm sensor, which measures the hot water temperature, and then just the flow and return in and out to it, if you're wondering why there's no zone valve on here. So once the floor's all tiled, I'll come back, get this in location, and then we can start to look at wiring it all in and getting the actual external air source heat pump in location. But in terms of the indoor unit and the actual cylinder, this is pretty much all I need to do. Now, depending on if you're retrofitting yours or if you've got underfloor heating and a mixture of radiators, you may need to add mixers, potentially a low loss header, but for me, this is all I need to do. So the more simple it is, the more efficient, the better this is going to run. So it is literally just flow and return straight into the manifolds. If it was up to me, I would actually just lose this valve altogether. So we'll see how we get on and what the customer says. So anyway, stay tuned and hopefully catch you on the part 3 of this video, and I'll show you how to install the external air source heat pump and get it all wired in. Thank you very much.